Moving on to section B, question number 21, it is said that usually it has been seen in offices chalk coil is needed in a fluorescent tubes with AC mains. Also, an ordinary resistor cannot be used instead of chalk coil. Why? What is the value hidden in this question? So for resistor, the power loss across resistor is maximum, like for resistor phi 0, so P will be IRMS dot VRMS, that is the maximum value. For inductor, phi can be 90 degree. So if phi is 90 degree, power used will be 0. So value hidden in this question is electricity saving. So question number 22. Draw suitable graphs to show variations of photoelectric current with collector plate potential for I1 greater than I2 greater than I3. So this is the graph for fixed frequency, but they have different intensities. Now in the second case, we need to draw a fixed intensity but different frequency, that is F1 greater than F2 greater than F3. So this will look like figure 2. Now moving on to question number 23, it says apply Kirchhoff law to the loops ACBPA and ACBQA to write the expression for the current I1, I2 and I3 respectively in the network. So if we apply Kirchhoff's first law, so it will be I3 equals I1 plus I2. That's for half mark. If you write this equation, you will get half mark. Now let us apply Kirchhoff law to find for the loop A, C, B, P, A. So it will be minus 12 I3 first, then it is going through 0.5 ohm resistor, so minus 0.5 I1 is flowing through this, then we have a potential difference of 6, so plus 6. So we get the first equation as 0.5 I1 plus 12 I3. Now in the second loop, ACBQA, ACBQA. So in A it will be again minus 12 I3, then in the second it will be minus 1 I2, then in the last we have a battery of plus 10 which is equal to 0. So we get two equations, that is I1 plus 12 I3 equals 6, I2 plus 12 I3 equals 10. So we just need to write the expressions for the current I1, I2 and I3. That's all. Question number 24. It says what kinetic energy of a neutron will be associated with de Broglie wavelength, that is 1.32 into 10 raised to power minus 10 meter. Mass of neutron is there. We need to find the kinetic energy. So we can find by using the wavelength formula, that is h over under root 2mn k. So like changing the value in terms of k, we get h square over 2mn lambda square. So putting all the values, you will get the value as 7.53 into 10 raised to power minus 21 joule. Now moving on to next, answer the following. Question number 1. The angle of dip at a location in southern India is about 18 degree. What would you expect a greater or smaller dip angle in Britain? Why in Britain actually we will get a greater value of angle of dip. Why? Because Britain is located very close to North Pole. Therefore, the angle will be about 70 to 75 in Britain. You don't need to mention the angle, but you can write that it will be greater than India. Why? Because it is more closer to North Pole. Now, in the second one, geologists claim that beside the main magnetic north-south pole, there are several local poles in the Earth's surface oriented in different directions. How is such a thing possible at all? So, as you know that Earth's magnetic field is only due to dipole field. So, as there are several local north or south pole, they may exist oriented in different directions so that they can nullify the effect of each other. If there are actually many north and south poles, then they can helpful in nullifying the effect of each other. Now moving on to question number 26. Define magnifying power of a telescope. Also write its expression. So in this you need to define the magnifying power of a telescope, like what it is equal to, and then you need to write the expression deriving it. So as you can see, magnifying power is F naught over Fe in bracket 1 plus FED. You can left it here as well. Now in the OR part of it, it says show that linear magnification of an image formed by a curved mirror may be expressed as magnification equals f over f minus u equals f minus v over f, where letters have their usual meanings. So as we know from class 10 basics, that is magnification is equal to h dash over h equals minus v over u. Now comparing this value to the value of mirror formula, we know we have 1 over v equals 1 over f minus 1 over u. Now using LCM of it, we get the value for v. Now putting the value of v in magnification formula, you get f over f minus u. Now we can even get the value for 1 over u. So 1 over u, when we find the value for 1 over u from mirror formula, we get this value, and overall we get f minus v over f. Now comparing these both, we get f over f minus u, or is equal to f minus v over f. So in the first, you can get the value of we can get the value of v. In the second one, you can get the value for 1 over u. So putting those equations, you get two different values of magnification. So that's the end for question number 26. Now the last question of section B is define mean value and root mean square value of alternating current. So mean value is defined as the value of alternating current which would send same amount of charge through a circuit in half cycle that is sent by steady current in the same time, and it is denoted by IN or IAV. Whereas in the case of root mean square value of alternating current, you can write it is defined as the average value of alternating current AC over a complete cycle, which would generate same amount of heat in a given resistor that is generated by steady current in the resistor and in the same time during a complete cycle. So that's the two definition of mean value and root mean square value of alternating current.